In this video, we are going to study omitted variable bias with Wald test in Python using Spyder IDE. As you can see at the bottom of the screen, this is an educational video only and no professional advice included within it. Okay, so let's go into Spyder IDE. So the first step within the video is we need to import the corresponding packages. Therefore, we comment this as step 1, which is packages. And we're going to import stats models.api as sm. We're importing that feature from stats models for data downloading. Then we're going to import stats models.formula.api as smf. We're importing that feature from stats models for multiple linear regression calculation and Wald test. To run these code lines, we select them and we can either click on the Run Selection button or press F9 on the keyboard. Then we continue with step number 2, which is data. For data, we're going to create an object named housePrices_object, which is equal to sm feature from stats models dot datasets dot get underscore r dataset, and we open parentheses. The first parameter, which is data name, equals to, and within quotations we have house prices, comma, enter on the keyboard, package equals to, within quotations AER, comma, cache equals to true. So what we're doing here is the following. We're downloading house prices object from our package AER, and with cache equals to true means that once we download the data, it saves it locally, so we don't need to go ahead and download it every time we run the code. Notice that this will download data and the documentation within house prices object. Therefore, we continue with the following code line, which is we create an object named house prices with only the data. Therefore, equals to house prices underscore object, and we get its .data attribute. To run these code lines, we go ahead, select them, and we press F9 on the keyboard. As we can see, within the Variable Explorer from Spyder, this created two objects, house prices object with data and documentation, and house prices with only the data. To view the data at any of these cells, we double click on them, and we see the data. In this video, we're going to focus on the first 4 columns of data of price, lot size, bedrooms, and bathrooms. The reason for this is that we have an original multiple linear regression in which price is the dependent or explained variable, and it has as independent or explanatory variables lot size and bedrooms. And we're going to add bathrooms as the new independent or explanatory variable, and we're going to test whether it was correctly or incorrectly omitted. So we are going to close this window, and if you want to read the full documentation on the data, you can do so with the following code line, which is print, and within parentheses we have house prices underscore object, and we get its dot 2 underscores doc 2 underscores attribute, and then we press F9 on the keyboard. As we can see right here within the console, we have the documentation. So we're going to scroll up, and we have house prices are documentation. Now that we have the data ready, we can continue with step number 3, which is the model. For this, we create an object named MLR, which stands for multiple linear regression, equals to, we'll be using SMF feature from stats models .ols function, which stands for ordinary least squares, and within parentheses the following parameters. The first of this, which is formula, equals to, and within quotations, because this is a string, price, and with this special character means being explained by lot size plus bedrooms, that's the original regression, plus bathrooms, which is going to be the regression for which we're going to test the omitted variables, whether this bathrooms was correctly or incorrectly omitted. comma, and we press enter on the keyboard, data equals to house prices object, the one we created above, and with dot fit, open and close parentheses, we fit the regression. Again, to run this code, we select it and then we press F9 on the keyboard, and we can see that this creates the MLR object within the Variable Explorer. Now that we have the model ready, we can continue with step number 4, which is omitted variable. And we're going to test this with Wald test. Therefore, we're going to create an object named Wald test equals to MLR object, the one we fitted above, dot Wald underscore test function, and we open parentheses. The first parameter, which is going to be R underscore matrix, equals to, and within quotations, we have the corresponding test hypothesis, in which we're going to test that bathrooms equals to 0, comma, use underscore F equals to true. So as mentioned previously, what we're doing here is the following. We have an original regression of price being explained by lot size and bedrooms, and a second regression of price being explained by lot size, bedrooms, and bathrooms. And with this R matrix of bathrooms equals to true, we're going to test that corresponding hypothesis of the omitted variable for bathrooms. With use F equals to true means that we are going to perform an F test. The F test is the joint null hypothesis that omitted variables coefficients are equal to 0. In this case, we're only including one omitted variable, bathrooms. Therefore, it's a hypothesis of one coefficient. Notice that omitted variables model, the one we created above, and the use F equals to true parameter were only included for educational purposes, and they can be modified according to your needs. So once we perform this F test, we want to print its results. Therefore, at the following row, we print Wald test. So let's go ahead and run these code lines. So we select them and we press F9 on the keyboard. And as we can see, we print the results from the Wald test. We have first of this, the F statistic, degrees of freedom, and last we have the p-value. So this Wald F test p-value has the null hypothesis that bathrooms omitted variable coefficient equals to 0 as specified within the parameters. If rejected, variable was incorrectly omitted. If not rejected, variable was correctly omitted. Notice again that tests can include different omitted variables model, as specified above, with a different specification and different probability distribution, the other option within this function, instead of use F equals to true. And both of this would depend on your specific needs. Okay, so with this, we finish the code, so we go ahead and save the file. And with this, we also finish this video. Thank you for watching.